kiddos. Today we're going to be talking about understanding rectangles as tiled squares. And that's our learning target actually. I can make a rectangle out of equal size squares. Now, understanding that you can do this with equal size squares in a rectangle is going to help you down the road when you're learning about fractions, because fractions involve equal size pieces. And it's also going to help you learn how to measure the space inside shapes in future grades. So this is just a really useful thing to be able to see when you're talking about shapes. Now, the first thing you'll need to understand is when I say tiled squares, that means we're thinking about it like putting a bunch of equal size squares in something, like you would for a tile floor, or maybe there's tile in a bathroom that's being like decoration around the sink or around the shower. But that's all that tiles are. They're equal size square pieces. Now, we've already been practicing making shapes out of other shapes. Remember the activity when we took the yellow hexagon and figured out all the different ways we could make that same hexagon shape, but using other smaller shapes. Now we're going to use that same kind of thinking to think about rectangles. We're going to be making rectangles out of these equal size squares, which we're going to also call tiles. I showed you with this picture of tile floor how we can do that. So here this red rectangle is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal size squares. You can also have different shaped rectangles made of equal size squares. Here's a tall skinny one made of 3 squares. And this blue rectangle has 3 rows. Remember, rows go across in a straight line, like sitting in rows at the movie theater. This one has 3 rows of 4. It has 12 squares in all. Oh, I forgot to mention, the third important math thing that you will think that thinking about rectangles as equal size squares will help you with is multiplication. There is a strategy for thinking about multiplication that involves this sort of thing. Anyway, let's keep going. So you can use squares that are the same size to make a rectangle. For example, here we put 12 squares in one row, one straight across the page, and this made a rectangle. Around the outside is a really long, skinny rectangle. We could take those 12 squares, this is the same picture as on the last page, and you could put them in 2 rows to make a different shaped rectangle. It still has 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But now they're organized differently. Now they're in 2 rows. The top row has 6 squares, and the bottom row also has 6 squares. You could figure out how many squares are in this rectangle by adding up the rows. 6 plus 6. 6 in the top row and 6 in the bottom row. And that still gives you 12 squares in all, just like this one where they were all in the same row. You could even organize this a different way. So here's our first 2 where they were all in one row, and then where we took the 12 squares and made them into 2 rows. Remember, this one was like thinking about 6 plus 6 because each row has 6 in it. But you could move the squares around one more time and make a shorter rectangle that has 4 in each row. 3 rows with 4 rectangles, or excuse me, 4 squares. We've still got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But now they're just organized a little differently. 1 row, 2 rows, 3 rows. 3 rows of 4, and we can prove that that's still 12. by adding up the 4 in the first row plus the 4 in the second row plus the 4 in the third row. 4 plus 4 is 8, and 8 plus 4 more still equals 12. So each of these rectangles has 12 squares, but they're all slightly different shapes depending on how many we put in each row. Before we go on, I want to make sure you notice that you could break the rectangle into squares or build a rectangle out of squares, even if the squares are different sizes. The important thing, though, is that within one shape, they all have to be the same size. So this rectangle uses squares that are the same size. Each of these squares is this big. 1, 2, 3 of those big squares. Let's label that 3 big squares. But the squares are equal, so this works. You could also think of it with the smaller squares. Notice how all these squares are still an equal size, but they're smaller than the big squares. In this case, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Using the smaller squares, it took 12 little squares to make that rectangle. It's the same rectangle, but depending on the size of your squares, you might get a bigger or smaller number. Bigger squares take less squares to fill it up. It takes more of the little squares to fill up a rectangle. But as long as they're the same size, it works. Now I kept that on the top of the page, but look down here. These are some examples of what not to do. These rectangles are not drawn using squares that are the same size. You can see in the one that has the blue, they used some big squares and some little squares. So this one doesn't work. You can't measure a rectangle this way because your squares are different sizes. It would mess up your counting. Over here, the problem is that they did do 2 big squares, but these green parts are not squares, so they didn't divide that shape into equal size squares. Equal size squares is going to be the really important phrase for this. When you're dividing a rectangle into pieces, they need to be squares, and they need to be equal size squares. You can't have some big squares and some little squares. Okay, so let's do some practice. Here's your assignment for today. On the first page, you're going to tell how many rows are in this rectangle, then tell how many squares are in each row, and then write a number sentence to show how you could add up that number in each row to get how many squares in all. And then down here, you'll tell the answer of how many squares in all. This page has a similar problem. You're going to write a number sentence that matches the number of squares in the rectangle, and then you're going to tell how many squares there are. Same thing here. Write a number sentence to add up how many squares are in each row, and tell how many squares are in the rectangle. On this page, there's a thinking question. These 2 rectangles are the same size, but the bottom rectangle has more squares. Why is that? Put your answer in here using a sticky note or a text box. And last one, draw lines to show 2 different ways you could fill these rectangles up with same size squares. Think about the last page where some were bigger and some were smaller, and see if you can use that to help you draw lines and fill these up with equal size squares. That's all for this video. I'll see you in the next one.